Hello, dear colleagues. Welcome to my presentation. My name is Abdülhamit Aksoy. I am a PhD candidate at Istanbul Technical University. And today I will talk about a part of my PhD study, which is the investigation of tribological properties of domestic fly ash containing composite brake linings. In this study, the tribological properties of brake linings containing domestic fly ash were examined. Friction brake linings with different constituents were produced using fly ash obtained from Yeniköy thermal power plant. The main function of friction brake linings is to slow down or stop the vehicle through friction. Features such as a suitable coefficient of friction, stable friction coefficient in a wide range of working temperatures, high wear resistance, low noise level, reduced vibrations during braking, and ability to be used in dry and wet conditions are the properties we desire in friction brake linings. Friction brake linings consist of more than 20 types of constituents. These are mainly classified as binders, friction modifiers, abrasives, and reinforcement materials. Apart from this, the cost of the friction brake lining is also an important parameter. In this context, studies are being carried out to use fly ash and waste tire rubber as constituents to lower the cost by using such waste byproducts. The use of waste materials in brake lining compositions provides significant gains in terms of both environmental and cost benefits. In this study, friction brake linings containing domestic fly ash and waste tire rubbers were produced, and their usability was investigated through tribological and mechanical tests. Fly ash obtained from Yeniköy thermal power plant and waste automotive tire rubber particles obtained from a tire recycling company were used in this study. As we can see from the table, we manufactured 4 different compositions with different amounts of fly ash and rubber, and the rest of the constituents were arranged to reach a 100% weight for the samples. As we can see, we have a sample 1 and 2. They differ with the amount of tire rubber they contain. Sample 3 and 4 also have the same amount of fly ash, and sample 3 has tire rubber and sample 4 doesn't have any fly tire rubbers. So for these samples, we will be able to observe the effect of both fly ash and tire rubbers on the tribological properties of the samples. Now, the fly ash content, also the chemical composition of the fly ash itself, has significant effects on the properties of the brake lining composites. So, as you can see from this table too, we have the chemical analysis of the Yeniköy fly ash. So, as we can see here, the SiO2 is at 29%, alumina has a 50.5%, and iron oxides have 4.1%. These 3 chemical materials are abrasives, friction modifiers, and wear resistance increasing properties. So this composition of the fly ash itself has an effect on the outcome of the study. The reason we selected the Yeniköy fly ash is because of the total amount of these abrasive friction modifiers and wear resistance increasing properties are about 50%. So it will give a good result in the study. After the manufacturing of brake lining samples, as we can see from this middle picture, you see in the bottom we have the brake pad just removed from the molds. And after that, we have some cleaning and machining operations on the brake pad to make it usable. Now, after that, we use the dynamometer on the right to do the tribological test. And after the tribological test, we can see the worn surfaces of the brake pads after the friction and wear tests. Now, apart from this, we also one of the important parameters in brake pads are density and hardness. The density and hardness of the materials were also measured, and also the worn surface analysis were done by a roughness measurement. And as we can see, the samples that contains rubber has a higher surface roughness than the ones that don't contain the rubber, meaning the rubber increases the surface roughness. And because of the rubber particles, also the porosity of the samples increases with the use of tire rubber. You can see from here. Now, the average coefficient of friction, normal and hot friction coefficients and performance values determined according to TS 555 standards were obtained for the 4 samples, which are shown in this table. Based on the difference between the normal and hot friction of coefficient, we give a, and also the value of them, we give a letters based on the TS 555. Pads must have an FF grade. Now the FF grade, as you can see for sample 1 and sample 4 are acquired. So we have accomplished to manufacture some commercial grade brake linings in this study. The GG sample 2 also has a good friction coefficient, but it is a little bit high for automotive usage based on its braking performance. And the sample 3 has a GF, meaning that the hot and normal coefficient of frictions differ significantly, as we can see from the values. So that's not what we want in the friction materials. Also, during the tribological test, one of the important properties is the wear properties of the brake materials. Values also were measured, and we can see them in the table 7. Now, we can see that the wear resistance of the materials is very high. They have a 0.5 to 4% by weight, which is very high. Now, sample 1 and 2, if we compare them, sample 1 and 2, the only difference between these two samples is that the sample 1 doesn't contain rubber, and sample 2 contain rubber particles. Now, the samples containing rubber powder wears more. We can see 0.5 to 0.49. And the friction coefficient also increases. We can see it from this table, from 0.35 to 46. Likewise, from the samples, we can see that the samples containing rubber powder at 25% by weight, fly ash, wears less, and the friction coefficients do not change significantly for the sample 3 and 4. Now, from this graph, we can see that the friction coefficient fluctuations are visible for sample 1 and sample 4, while sample 2 and 3, which includes tire rubbers, fluctuates more steadily. Now, the high fly ash content has in sample 4, we can see for the sample 4 and sample 1, they fluctuate very rapidly by the break applications in the wear phase. But sample 2 and 3, they fluctuate or they show a more steady friction coefficient. Now, although the sample 2 and 3, they have different fly ash ratios, they both showed a very stable friction characteristics because of the viscoelastic property of tire rubber particles. Also, an SCM analysis of the worn surfaces showed that the main wear mostly occurred on the brass particles or brass shavings, which are the hardest point or hardest locations in the brake pad. And the secondary wears on the rest of the constituents is visible after the brass particles wears and give way to the wear on the other portions of the brake pads. Now, in this study, as a conclusion, the tribological properties of composite friction brake linings with fly ash and waste tire rubber were examined, and the usability of these two waste materials in commercial friction brake linings was investigated. As a result of the research, the following results were obtained, which are in line with other studies in the literature. It was concluded that as the amount of fly ash increases, the density and hardness of the friction brake lining decreases. Inclusion of waste tire rubber particles to the composition provides a stable friction performance by reducing the fluctuation of the friction coefficient. The manufactured samples with fly ash and tire rubber have similar performance characteristics, meaning FF grade markings, as commercial friction brake linings and are suitable for commercial use. And the use of waste tire rubber particles decreased the wear resistance and increased the wear loss. Thank you for your attention.